Yes, ma'am.
And then you flip heads.
Yes, ma'am.
And then it takes you like 3 more times to flip tails again.
That's okay. All I'm asking is you to repeat one of the 2 occurrences. You're answering the next question, which is, suppose you flip tails first, and then I want you to flip that one again at some point. You could theoretically go heads, 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 until you got tails again, yes? You could. But all I want you to do is to repeat one of the 2 faces. If you flip heads and then tails, whatever you're going to get next is going to match one of the original ones.
Oh, okay.
Is that, yes?
That makes sense.
It's kind of like you have, here's a different one. You have 2 pairs of socks in a drawer. And all you want to do is you want to leave the house with a matching pair of socks. And you reach in and you grab one and it's red. And you reach in and grab another one and it's a non-red Argyle. Whatever you grab next is going to match one of those 2.
Yeah.
Because you only have 4 socks in a drawer, right? Assuming there's 2 matched pairs in there. You're going to reach in and either grab a red one or a non-matched Argyle. Fair? Does that make sense?
Yeah.
Good. I misspoke it the first time I said it. I said match the first one. So I misspoke the first time. And I went back and you guys are so good, you listened to me right then. Now I said, no, that's not what I meant. I meant matching any of the flips that you get.
Okay.
Cool. So that's why we can have a max of 2, or a min of 2 and a max of 3 flips. All right, so we now know, and the reason I like leading us towards this, we need this idea for understanding craps. I was trying to think of how to link this together to the idea of craps, and this is a pretty good way to start. Because what you're about to understand right now is something called a distribution of outcomes, which is an organized way of summing all of our data together. So what I'm going to do is, I'm going to make a little T-table like we did with the flu virus. So this is number of flips. Let's keep track of the experiments. Experiment number 1. Experiment number 1 is flip a coin until we get a repeat. Flip a coin until we get a repeat. We're going to come back and I want to address your point momentarily, and also something that Carrie and Kendra were talking about earlier too. So this is flip a coin until we get a repeat somewhere, whether it's a repeat of heads, repeat of tails. Now hopefully you guys make sense. You're only going to flip it 2 or 3 times. I mean, if you flip it twice, if it goes heads, heads, or tails, tails. You flip it 3 times, if you get a mismatch in the first 2, because whatever you get in the third is going to match one of the first 2 that you did. Fair enough, hopefully fair enough. So my question is, how many times, let's collate our data right now. How many times did people get exactly 2? So you each did it 10 times, right? You each did it 10 times? Raise your hand and show me with fingers how many times you got 2 outcomes. I'm going to try to add this up as I go around the room. How many times did you get 2 outcomes? All right, so this is very, very interesting. I love this. I love seeing these hands. I'll show you a scan picture of it. Actually, would you guys mind?
Oh my.
Just your hands. Would you mind? Hold on nice and high. Would you mind if I did this? Because you're actually illustrating the idea perfectly. I'll post it for you tomorrow. I'll email it to you tomorrow, actually. Because you're demonstrating, it goes back to Randall's question. Hang on. Yeah, this is great. Make sure I can see both your hands kind of close together. And around. There we go. Oh, that's freaking awesome. Yes! Boom. Thank you, friends. Put it back up. I didn't count you. You thought I was counting while I was doing that? My God! All right, so we got.
You probably need your calculator. Right?
I probably do. Thank you. You know me far too well, brother. All right. So 4 plus 4 plus 4 plus 5. I'm going across the front here. Plus 6 plus 6 plus 8 plus 2 plus 4 plus. Whitney, that's 6, yeah?
Yeah.
6 plus 6 from Alexa. Tara, how many you got? None?
I think I did it wrong.
That's okay. We'll leave you out. It's totally fine. I got you, Haley. Plus 5 plus 7 plus 7 plus 6 plus 6 plus 6 plus 7 plus 8 plus. Brady, how many you got?
Oh, 7.
You got 7? Plus 7 plus 5 plus 6 plus 5 plus 7 plus 4 plus 5 plus. Tell me how many you got? You got 5 plus 5 plus 5 plus 4. Thank you, my friends. That's 160. That's 160 times we saw you guys need 2 flips. Which means you either went heads, heads, or tails, tails. So if you had to make an assumption about how many times you went heads, heads, what would you guess? If you had, so 160, you either went heads, heads, or tails, tails, correct? This was either heads, heads, or it was tails, tails.
Yeah.
So if you had to guess how many of these were heads, heads, what would you guess?
130.
130?
There's 200. Well, there's 29 of us.
Of this 160,
Yeah.
how many would have been, do you think, just heads, heads?
80.
Half of them, right? Hopefully that makes sense. Half of those results would have been heads, heads, roughly, and half would have been tails, tails. I'm not sure who kept track of that. I didn't tell you to keep track of that, but that's okay. Do you everybody see how that's a legitimate guess? That's a legitimate guess, correct? Because, assuming that the coins are being flipped randomly, you should see just as many heads as tails. So 2 heads should be just as likely as 2 tails, hopefully. Assuming the coins are fair and we're flipping them consistently. That's what we're seeing up here in Excel, right? Beautiful! Now, how many people were flipping? Did everybody flip? Everybody do the experiment? Everybody did? Do we still have 2,209? Let me just, 1, 2, 3, 4, 5, 6, 7, 8.
There's 29.
9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I was going to make sure they were still here. So 29 people flipped 10 times each. So if 160 of them got this, that should mean 130 down here, right? Is that fair? Is that fair? Because that sums to 290, and I can do that. I want to make sure there's still 290 in the room. Assuming you all did the experiment, we should have 130. And that'll save you the agony of having to count up all those hands and screw it up again. Okay, now my question is this. I want to leak some statistics into this. On average, how many flips does it take until we see a repeat? On average, how many flips does it take until we see a repeat? This might sound kind of dumb. It might sound, well, why would you ever care about something like this? Well, I think it's Progressive Insurance that offers a rebate. Even if you've gotten a ticket in the past, if you then go a long period of time without getting a second ticket for the same offense, they give you some kind of a rebate on your insurance. What they've done is, they've calculated an average like this based on insurance and accident records. And they said, oh, after X years, on average, people will either repeat or stop repeating having accidents of the same kind. Therefore, we can offer an incentive for lack of a repeat. See what I'm getting at, friends? So, how could we figure this out? How could we figure out, on average, how many it takes? What do you think?
To add them all up and divide by 4.
Well, that's something we've... Thank you, Taryn. Who remembers the rule for averages? How do you find an average?
Add them all up.
Average, from way back in the day, how do you find an average?
Add them up.
Add up all your data. And then do what?
Divide by how many are.
Divide by the number of the data. Love it. Love it. Fantastic. How many data points do we have? 290. We know that over here.
Divided by 2.
Now, the question is, how do we add up all the data? So my first question is, where are the data? Which of these numbers are the actual data? And this is, again, I'm trying to prep you guys for 243 a little bit here. If those of you taking 243. Where's your actual data? What were we interested in doing the experiment? Say that again. Nice and loud. The number of trials it took us to get repeats, yes? So which ones of those are the data? Aren't those the data points? So what are these over here? Yes! How many times we saw each of those data points. So to do exactly what Taryn just told me I need to do, I'd have to go 2 plus 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 2. How many times?
A lot.
160 times.
So would you go 1
Plus 3. Let's count, please. 3 plus 3 plus 3 plus 3 plus 3 plus 3. How many times? Okay, that's ridiculous. That's why, as humans, a couple hundred years ago, we decided to invent something called multiplication, which kind of undoes all the repeated addition stuff. So, what I want to add to your arsenal today, I love the fact that how many of you guys went right to this when I said the word average? Add up all the data and divide by how many's like, yes, I've heard that before, we've done that before. Good. What we're going to add to your arsenal today is something called a weighted average. A weighted average. This is one of our favorite things, and this is what we need to understand for craps. And for just about anything, actually. This is how